All right, I'm going to go over problem 4.35 in perusal for part of my project. So this is very similar to 4.31 and 4.34, I believe. And so we're going to be doing the same exact thing. It's a little bit trickier than the other ones. So let's first take the gradient of this. So the gradient of f. So for the first part, we want to make the y's constant. So, and do it in respect to x. So this will be 12x, and that minus 6x squared. We got that. Oh, and there it is. There's a y that could be constantized. So then it would be 6y plus 6y. Sorry, it might look a little weird. 6y. Okay, cool. And now we can do the y part. So the x's will be constants. So I'll make this one a 6y because of this right here. And then, sorry, that's a y, trust me. And then we can make this x right here constant, so that would be 6x plus 6x. Cool, cool, choo. All right, so now what we've got to do that matrix again. And do the x side in respect to x right here. So this will be 12 minus 12x. There we go. And then in the y, so there's a 6 right there. Respect to y. All right, and then a 6 right here, and another 6 right here, because the 6 right here, and the 6 right here. So it turns out we have 3 6's in this matrix. Cool. And so thank heaven for Brother Woodruff, because he already gave us the critical points. So we needed to put in the x values right here. So let's make these new ones blue. So for this one, it's going to be 12 minus 12 times 0, because that's the x value right here. And don't worry, we'll do the one on the next one over here. This one will be 6, 6, and 6. Cool. And then, so we could solve for that. So 12 minus 0 equals 12. So this will be 12 minus a lambda. And that times 6 minus lambda. And then we'll do minus 6 times 6, which is 36. And make that equal to 0. Man, this one's having us do math. So 6 times 12 equals 72. Then we gotta do the first outer inner last for FOIL. And I'll end up to minus 18 lambda plus lambda squared. And then we got 36 out there, so minus 36. So it's going to turn out to lambda squared minus 18 lambda. And then 72 minus 36 equals positive 36. So if you want to use the quadratic formula, you can, that'd be cool. But the thing with me, I have a nice thing called a graphing calculator, and it can do it for me. So would it made it equal lambda 2 equals 2.29. Remember, this is positive, 2.29. And about 15.7. Cool. And so that's what we're going to be using for this point right here. So 0, 0. So at 0, 0, there's going to be, because it's positive and positive, it's going to be minimum. So let's see. So minimum, it's creeping under. All right, cool. So now let's move on to the next matrix right here. So instead of putting the 0 in right here, we'll put a 1. So this makes things a lot more interesting. So 12 minus 12 times 1. Oh, what you know? It's 0. And a 6, 6, 6. So it's going to be 0 minus lambda. And that times 6 minus lambda. Oh, and that minus 36. Here, I'll take care of that. All right, cool. And that will equal 0, just like the other one. All right, cool. So what we can do, remember this is a negative lambda. Sorry, it looks a little weird. So this will just be lambda squared, because negative lambda times negative lambda, and that minus 6 lambda, and that minus 36. Ooh, that's a pretty number. So that would be lambda minus 9 and lambda plus 3. Alright, cool, that equals 0. Let's solve for that. And lambda could either be 9 or negative 3. And as we see Brother Woodruff's handy dandy pictures again, see, one was positive, one was negative, so that's going to be a saddle. And like I said, for the first one, both are positive, so it's going to be minimum. So this right here is just going to be a saddle. You got to remember which point is which. So it's going to be a saddle at this point right here, because this is the one that we use to go right here. And it's going to be a minimum at this point, this critical point. That's going to be right there. And that's how you do it.